All right, last one, definitely a calculator problem. Let R be the region in the first quadrant bounded by the graph of y equals x squared. So there's your x squared, right? So below by that graph, and above by the square root of x. So that's going to look like this, right? So this is the square root of x, and this was x squared, kind of like that. So R is that region. These intersect at 0 and 1. If you can't spot that, you can also do it in a calculator. It's not a big deal. So R is the base of a solid whose cross sections are perpendicular to the x-axis and are squared. So it looks like this. It's a square coming off of here, right? What is the volume of the solid? So the area of the square is going to be side squared, but one side of the square is top minus bottom, right? So the side is going to be top, which was root x, minus bottom, and then it's all side squared. So my volume is going to be the integral from 0 to 1 of all of those areas. The trick here is that it is all on you to be able to figure out that that's the setup. Your calculator can do the integration, but you really have to understand the concept. So I always put them in the order that they're given to me. So I would put the x squared first, and then I'd put the square root of x, because that's just how my brain works. And I'm going to go ahead and, I could zoom 6. I'm going to zoom 6 to show you why it's not great, because I want this little window right here. So I'm going to go ahead and zoom in. I could zoom and specifically pick the window I want because I know what window I want, but I'm just going to zoom in like this. So this is that area that I drew, right? So I called this guy my y1, which is notation for me, not for the AP. The AP doesn't care about your calculator notation. So what I'm going to do is I'm going to do function integrate, right? And then in parentheses, I'm going to do y2 minus y1 quantity squared with respect to x from 0 to 1. And if these didn't have nice happy points of intersection, you would have actually had to find the points of intersection, but in this particular instance, they have really nice points of intersection. So I could have second calc intersected and I'd get 0, 0, and second calc intersect and I get 1, 1. But here they're pretty nice. So I'm going to go ahead and do math 9, right? So math 9, in parentheses, vars over to y vars function. I want y2 minus vars over to y vars function y1, parentheses, quantity, oops, sorry, I meant squared, comma, with respect to x from 0 to 1. And I hit enter, and I get this, which seems to be this guy right here. And that's it.